Physics is the branch of science that deals with the study of natural phenomena in terms of basic laws and physical quantities. The word physics is derived from the Greek word physis, meaning nature or a part of the natural environment. The scope of physics can be divided into two major domains that are macroscopic and microscopic. The macroscopic domain deals with phenomena at laboratory, realistic, catastrophic, and astronomical scale. Whereas the microscopic domain deals with molecular, atomic, and nuclear phenomena. In our study of physics, we will look at microscopic phenomena under classical physics that includes mechanics, electrodynamics, optics, and thermodynamics. In physics, we attempt to explain various physical phenomena in terms of few concepts and laws. We see the physical world as manifestation of some universal laws in different domains and with the required conditions applicable as per the contexts. For example, the law of gravitation, which describes the motion of an apple detached from a tree which eventually falls to the earth, also explains the nature of the forces between Earth and the Moon, and also the forces that bounce the planet in the solar system in their orbits and keeps them in motion in their paths. Thus we derive the properties of bigger or more complex system from the properties or interaction of the similar parts or constituents of the system. This approach is called reductionism and helps in understanding the properties of complex systems in physics, like functioning of satellites, etc. Physics is closely connected to technology and society. Most of the modern technologies are contributions from the realm of physics and work on one or the other scientific principle. Here are some of such technologies. These contributions came from all over the world. Here is a list of some notable physicists. These contributions came through observations, experimentation, or analysis of natural phenomena, and the realms or laws that govern such phenomena. These gave us the knowledge of fundamental forces in nature and physical laws. There are 4 fundamental forces of nature, and all other forces we know are derived from these forces. These fundamental forces are gravitational force, electromagnetic force, weak nuclear force, and strong nuclear force. The gravitational force is the force of neutral attraction between any two objects by virtue of their masses. It is a universal force, meaning all objects in the universe exert a gravitational force on each other. We are able to stand or walk due to Earth's gravitational force exerted on us by the Earth. Exerted on us by the Earth, electromagnetic force is the force between two charged particles. Like charged particles repel each other and unlike charged particles attract. Like gravitational force, electromagnetic force is also universal and can act over very large distances. We do not usually encounter this force on Earth, as most of the matter around us is electrically neutral. Hence, of the two forces, gravitational forces dominate all terrestrial phenomena. An atom consists of 3 subatomic particles, namely electron, proton, and neutron. The force that binds protons and neutrons is a strong nuclear force. weak nuclear force comes into existence in case of beta decay of the nucleus. In beta decay, the nucleus emits an electron and an uncharged particle called neutrino. Apart from finding the facts in observations and experiments, physicists always try to summarize these facts as laws or empirical relations in form of mathematical equations. These are known as physical laws. Most of these laws are based on some special quantities that remain unchanged in a process, which are known as convert quantities. Some of the general conservation laws in nature include the law of conservation of mass, energy, linear momentum, angular momentum, charge, parity, etc.